dimensional heat equation by means of Fourier series. That's it. Okay. And in there, what we have done. So we found that is we are taking the solution of the given heat equation, that is u of x t, isn't it? U of x comma t equal to f of x into g of t. That is we are taking u of x comma t equal to f of x into g of t, and now we are finding what is our f and what is our g, and we found that f1 of x is equal to sine of n pi, isn't it? Sine of n pi by L x, where n equal to 1, 2, 3, etc. So this is we have, up to this we have done, and also we have done this, that is g dot, we have g dot plus c square into n pi by L the whole square. This is p. Into g equal to 0. So we are having this equation. This is equation number 3, isn't it? Equation number 3. And we found that the solution for this also, if I take lambda n equal to c n pi by L, this equation is g dot plus lambda n square g equal to 0. Therefore, what is our g? We can write g dot by g equal to minus lambda n square. So integrating, this is log g equal to minus lambda n square, and g is a function of t, therefore this is t plus some integrating constant is c. Here I have taken cn or some an. Why this lambda, this c is not a fixed constant? Because this n varies, where n is, how the n got, the n is obtained from p equal to n pi by L, isn't it? P equal to n pi by L. Here instead of here we are having c squared k, that is k is p square, therefore c square p square g equal to 0. What is our p? P is n p by L, where n is equal to 1, 2, 3, etc. Therefore, when n equal to 1, you are having g dot by g equal to minus lambda 1. And when n equal to 2, you have g dot by g equal to minus lambda 2 square and so on. Therefore, we have countable number of equations. For each equation, you have one constant. Therefore, I can take Cn here. Okay, Alan, you have found out in the last class. So, for different lambda, we have different constants. So, for different lambda, we have different equations. For each equation, we get one integrating constant. So, we have log g equal to minus lambda n squared t into Cn. I take this as e raised to minus lambda n squared t plus Cn equal to g. Thus, this gn can be taken, g can be taken as e power Cn is, I have taken e power Cn as bn, e raised to minus lambda n squared t. Okay, but bn is taken as e power Cn. Okay, but bn is constant. Therefore, for each g we are getting like this. Therefore, I consider this g also gn. Okay, that is not a problem. Therefore, this u, instead of u, you are having now un of x comma t. That is u1 of x comma t will be f1 of x into g1 of t. Therefore, f1 of x into gn of t. What is f1 of x? f1 of x is sin n pi by Lx. And the gn is into bn e raised to minus lambda n squared into t. So that is equal to bn sin n pi by Lx e raised to minus lambda n squared into t. This is un of x comma t. So where n equal to 1, 2, 3, etc. Therefore, these UNs are solutions of the heat equation. That is, what is our heat equation? The number, I don't know what is the number I have put. So this is our heat equation, isn't it? Some c square dou square u by dou x square. So this is the solution of our heat equation. Okay. So this is, suppose what is the number here? This is the solution of heat equation. What is the number? I don't know. I just put here star. So equation star satisfying the conditions u of 0 comma t and u of that condition. So I think the condition will be 2 and 3 or 3 and 4. What are the conditions? It is satisfying the condition, that is u of 0 comma t. You have this, no? And u of L comma t. So satisfying these two conditions. I don't know what is the number satisfying equation 1. Now I have put this is equation 1 and this is your equation star. You just check in your note for the last day class. Okay. Actually, this will give you the solution of this equation, isn't it? But we have to find the entire solution. That is, to get the solution which is satisfied. This will satisfy only this condition. But actually, we have another initial condition also, that is f of 0 and f of, that is what f of 0 and f of L. Both are also 0. So we have to find the solution which satisfies these initial conditions also. This initial condition is nothing but, what is our f of x? F of x is u of x comma 0, isn't it? So satisfying this initial conditions also, we have to find a solution which satisfies this initial conditions also. That will give you the solution of this problem. Okay, now we have the solution of this problem satisfying only this initial conditions, these two initial conditions, but we have to find the solution satisfying these initial conditions also. Okay, so how to find that? How to find? Up to now, how many equations number we have? I need one number for this. Can you give a number for this? Un of x comma t equal to, can you give a number 7 or 6? This one. Continuous number I want.
Ma'am, we have written 7 in the last class.
7 in the last class. So shall I take 8? What is our second?
For that same equation, we have written 7. Un of x comma t equal to bn sin n pi x by L.
This one.
Yes, ma'am.
Then I have taken the 7. This is our 7. Okay. The same equation means it is okay. Thank you. Now our aim is to find the solution which satisfy the initial condition, this f of 0 equal to 0 and f of L equal to 0. Okay. So solution of entire problem. So to get a solution, so what is the number for this initial condition? Whether it is 2, f of 0 equal to 0, f of L equal to 0 is equation 2, isn't it? If it is star, if it is 1, then it must be 2, I think. Yeah, okay, thank you. Thank you. So to get a solution which satisfies initial condition. initial conditions 2. Okay, initial conditions 2. Also, we consider a series of the functions un of x comma t. That is we take u of x comma t equal to sigma un of x comma t. This is equal to sigma, this is Bn sin n phi by nx e raised to minus lambda n square t, etc. n equal to. So from 2, what you get, u of x comma 0 equal to, from 2, what is u of 0 comma 0, isn't it? U of x comma 0 is f of x, isn't it? This is our function, but this is not true. This is not u of x, isn't it? Okay, from 2, when t equal to 0, u of x comma 0 equal to this. You substitute here t equal to 0. Sigma bn sin n pi by nx e raised to 0 is 1, isn't it? When t equal to 0, this is x, this is t. But u of x comma 0 is f of x. N equal to 1 to infinity bn sin n pi by nx. Okay. So to satisfy, this is similar to the Fourier series, isn't it? Therefore, to satisfy equation 2, okay, by the above expression, above equation, I can take above equation itself. This is an equation. Above equation, the bn's must be the Fourier coefficient, isn't it? The coefficient of Fourier sine series. Because it is sine of n pi by nx, therefore f of x equal to some series expansion. Therefore, to satisfy the initial condition, that is u of x comma 0 equal to f of x, must be equal to this expansion, provided this bn must be the Fourier sine coefficient of Fourier sine series. So what is our bn then? Therefore, bn equal to, since coefficient of Fourier sine series is bn equal to 2 by L integral 0 to L f of x sine n pi by nx for n equal to 1, 2, 3, etc. So thus, this is your u of x. Thus, u of x comma t equal to bn, where bn is nothing but the coefficient of Fourier sine series. Or bn equal to, I can write here, where bn equal to 2 by L integral 0 to L f of x sine n pi by Lx dx. So this is the general solution of the given equation. That is, the heat equation has the solution in Fourier series form. Okay. Actually, when t tends to infinity, that is t is time, t tends to infinity, e raised to minus infinity is 0. Therefore, this tends to 0. Okay. Therefore, this u of x comma t will become 0. That is, the rate of decay increases with n. That is the meaning. Okay. What is the u? U is the temperature. When time tends to infinity, the temperature is tends to 0 like that. Is it clear? In problem, when you are doing problem, you just carry out the procedure, or you can make it water. You can do the problem separately also. Okay, in both ways you can do. Now I am doing water. That is for any one dimensional. That is here you are having one dimensional heat equation, that is dou u by dou t equal to some c squared into dou squared u by dou x squared. This is one dimensional heat equation, and this, you are given, or you are asked to find the temperature of some metal or some region or some plate, etc. And this is here we are having the particle, or the temperature is moving or transfers in a linear way. That is in a line. Okay, in a straight line. It travels along a straight line. So either we can do as in the procedure, that is we have just to solve the equation, that will give you the general solution. Particularly, suppose if you are given a problem and find the temperature, and either you can use the previous model, or that is in that situation you have to first write the previous model, then you have to substitute the values from the given problem, or you directly do the problem as in the previous case. Okay. So I give one problem, then you may understand. So find the temperature distribution in a homogeneous bar of length pi, which is insulated laterally. Insulated laterally. Okay. If the ends are kept at zero temperature, and if initially the temperature is K at the center, okay, K at the center of the bar, and falls uniformly to zero at its ends. So you have to find the temperature distribution in a homogeneous bar of length, that is in the same material. You are given a bar of length pi. So I have taken a bar, this is pi, this is 0. I have given a bar of length pi and it is homogeneous and it is insulated laterally, and if the ends are kept at 0 temperature, here the ends are kept, so that is temperature is 0 at the end points. That is, shall I take the temperature? That is U, isn't it? U at the endpoints are 0. So what about the X? We don't know. So at the endpoints, the temperature is 0. And if initially the temperature K at the center of the bar, suppose if we take this is the center, what is the point here? This is 0 and pi, the center will be the midpoint of the bar. So the midpoint will be pi by 2. Okay, the midpoint will be pi by 2. So at the center, the temperature is, if I mark the temperature is K. At the midpoint, the temperature is K and falls uniformly to 0 at its ends. So at falls at the end points, it is 0. And here at the end point is pi, the temperature is 0, like this you are having. Okay. And now we want to find what is the position. This is, what is this point? If I consider as a plane, but the temperature is moving here only, it is rod is here, the temperature varies from 0 to K. So the at the center the highest temperature is K and at the end points the temperature are 0. It is given. Okay. But we don't know what is the curve, what is the function u of xt, what is the temperature u of xt. We have to find the curve. That is u of x comma t. We don't know. So if you know the function or if you know the initial condition, then only we can do the problem, isn't it? But the temperature distribution is, it is homogeneous and it is laterally insulated. Therefore, the equation is dou u by dou t equal to c square into dou square u by dou t square. So we have to solve this equation satisfying the initial condition. That is, here also the initial condition is whatever the time u of 0 comma t is 0 and this is u of, what is this? Pi, isn't it? The total length is pi and this is a temperature T. U of 0 comma T and pi comma T. This is also 0. Is it okay? This is given. At endpoints, the temperature is 0. Therefore, these two are given. This is the initial condition. And one more thing we have to find as usual, and we have to find what is your u of x comma 0. How to find u of x comma 0? x varies, and here it is 0 to pi by 2. The pi by 2, it attains its peak value, that is k. Okay. So if I take x-axis, the x value at x, and here it is the temperature, then it will be u of x comma t, that is u of x comma 0. We have to find what is our u of x comma 0. Therefore, this point can be taken as pi by 2 comma 0, isn't it? When x value, that is x distance is pi by 2, the temperature is k. Here, when x distance is 0, the temperature is 0. Okay. And here the x distance is pi and the temperature is also pi. The temperature is 0. What is this? This is pi comma 0, this point. So here what is this? 0 comma 0. Is it okay? This is x position. This is the temperature position, temperature value. So now we have to find what is our u of x comma t. For that, first we find the equation of the line joining this. First you find the equation of the line joining these two points. So the equation of line joining 0 comma 0 and pi by 2 comma k. So this is x1, y1 and x2, y2. If equation of the line joining x1, y1 and x2, y2 is, you may study in your lower class, that is, what is this? Y minus y1 by y2 minus y1 equal to x minus x1 by x2 minus x1. So by using this, what is your, this is x1, y1, this is x2, y2. So what is this? Y minus 0 divided by k minus 0, equal to x minus 0 by x minus 5 by 2. So what do you get? Y by k. Is it okay? This is 5 by 2 minus 0. That is y into pi by 2 equal to kx. That is y equal to 2k by 5x. So this is the curve here. This is the line joining these 2 points. Similarly, we have to find this line also. Okay. So the equation of line joining pi by 2 comma k and pi comma 0 is the same manner. Y minus, this is x1, this is y1. So k divided by y2 is 0 minus k equal to x minus, x1 is pi by 2 and x2 is pi minus pi by 2. So y minus k equal to minus k x minus pi by 2. So this is pi minus pi by 2 is pi by 2. I bring this pi by 2 here. So therefore y minus k equal to minus kx. No. Minus k to 2k by 5 x minus pi by 2. Therefore y equal to k minus 2k x by 5 plus 2. Okay. Anything, any other? Y minus k, 0 minus k, x minus, this is pi by 2. Second, right. So this is pi by 2, that can be written as 2k by 5, isn't it? So I write this directly. So what is this? Therefore y equal to k minus 2k by 5 into x minus 5 by 2. Okay. This is k minus 2k x by pi plus 2 pi will be cancelled. I get just k. That's the correct. It is 2k minus 2k x by pi. If I take LCM, this is, I can take pi. Okay. I take 2k by pi outside, I get pi minus x. Is it okay? So this is y. I take this is equation 1, this is equation 2. So you can see what is your y. This y is, this is y here, the value of the function, that's all. Isn't it? The curve, the equation of the curve. This curve is denoted by y equal to 2k. This curve is denoted by y equal to 2k by 5 into x, and this line is denoted by y equal to 2k by 5 into 5 minus x. Okay. Therefore, from 1 and 2, what we have got is, from 1 and 2, u of x comma 0 equal to this is 2k by 5x, where 0 less than or equal to x less than or equal to 5 and 2k by pi into 5 minus x if 5 by 2 less than or equal to x less than or equal to 5. Okay. And this is another initial condition we have. This is equation 3, I think. So this is our f of x initially. U of x comma 0 is taken as f of x, isn't it? Therefore, this is our f of x. F of x will be, that is, we are denoting y. F of x. This is x. This is x. I take this as y. So y is taken as our f of x. F of x is nothing but u of x comma 0. Okay. Y is nothing but f of x. F of x is nothing but u of x comma 0. Therefore, I directly write u of x comma 0 equal to 2k by pi into x, where x lies between 0 to pi by 2, and one more thing, I have taken equality in both the side. When you put x equal to pi by 2, what you get, this is k, and here also if you put x equal to pi by 2, you should get k. Otherwise, you should not put equal in both sides. That you have to keep in your mind. Okay. Now, we have to, now just we have found what all the initial conditions. What are the initial conditions? It is given u of 0 comma t is 0 and u of pi comma that t is also 0, and this is f of x. F of x is given like this, that is u of x comma 0, and now we have to find the temperature distribution. Okay, and the temperature distribution is given in a partial differential equation. Because it is a homogeneous and insulated, laterally insulated bar, so the equation will be the same. The temperature distribution is temperature distribution or heat flow equation, both are one and the same distribution. U of x comma t is given by dou u by dou t equal to some c square dou square u by dou x square. So I take this as usual, I take this as equation star. We have to solve this equation star. Okay, we have to solve this equation star, satisfying the conditions u of 0 comma t, isn't it? 0 comma t is 0, u of pi comma t is also 0. It is given. Initially it is 0. This is for all t greater than or equal to 0. And this is also for all t greater than or equal to 0. I take this as equation number 4. Okay, equation number 4.
Ma'am,
Yes,
here T is time or temperature, ma'am.
temperature is Q is your temperature. U is your temperature. That is temperature is given by means of this differential equation. U is your temperature, T is always time. Yes. U is your temperature. If T denotes temperature, in general, the temperature is denoted by capital T. It is not small t. If it is small t, then it is time. Okay. Then, now what you have to do? Usual procedure is you have to take u of x comma t equal to f of x into g of t, and here k cannot be, that is you have to solve the equation, and k cannot be negative, k cannot be 0, and k must be k cannot be 0, k cannot be positive, and k must be negative, isn't it? So we have to proceed the entire thing. Okay, but I am not discussing what k is positive and k is negative, k is 0 cases. Okay, when k is positive and k is 0, this u of x comma t will be tends to infinity as t tends to infinity. Therefore, u of x comma t remains finite when t tends to infinity in this case. Okay, so I directly write put u of x comma t equal to f of x into g of t. Then the equation or the equation star will become. So how will I write dou u by dou t is with respect to t, this is f of x is like this and g dot of t. And dou squared u by dou x squared is f double dash of x, and g of t, it is independent of, here you can write, here what is your f, where f is function of x alone and g is a function of t alone. Okay, f is function of x alone and g is a function of t alone. Therefore, we can find the derivative, and g dot is nothing but dg by dt, and f dash is nothing but df by total derivative. Because it is a function of x alone, a partial derivative will become total derivative. Therefore, the equation star will become this is star. The star becomes, what is your star? Dou u by dou t is f g dot. Okay. So if you are familiar, no need to write this f of x. Instead of f of x, you just write f. Okay, this is equal to some c squared into f double dash g, isn't it? Now we separate variables, separate variable separable method, that is g dot by c squared g equal to f double dash by f. So this is the right hand side is, this is the right hand side. Right hand side is a function of x alone. This is left hand side is a function of t alone. Therefore, these two are equal. Therefore, this must be equal to some constant. K is a constant. Okay. So two different variables, that is two different functions. Okay, in two different variables, they are equal. Therefore, they must be constant. That is the meaning. So by taking the first one and the second one, we are getting from first one g dot equal to c squared kg and f double dash equal to kf. This implies, that implies g dot minus, we get two differential equation, c squared kg equal to 0 and f double dash minus kf equal to 0. Okay, these two are, this is the equation 5 or 5. Okay? You are getting two differential equations. The same procedure we are doing. Here we are not discussing what is why our k is why our k is negative. We are not discussing why our k is negative because we have done all the explanatory work in the previous problem. So I just skip that and taking when k is negative. Okay, when k is negative. So, or you can write in one line k equal to 0 and k equal to 0 and k greater than 0, k equal to 0 and k greater than 0 are not possible. Okay, you can write in a single line because the problem itself very lengthy, so you can cut short after you understand the problem. Okay, therefore, when k is negative, we have k will be minus p square. So p square of anything is always positive. So minus p square it is negative. Therefore equation 5 becomes g dot. So minus is plus c square p square equal to 0 and the f double dash plus p square. F equal to 0. Now, so we got to solve this equation, that is g dot equal to minus, this is one g I have missed. So c square p square into z, that can be written as, this can be proved by g dot by g equal to e raised to minus c square p square, isn't it? So like that we have to solve this equation. So what you get, this is, shall I write directly? The same procedure. G dot equal to minus c square p square g implies g dot by g equal to minus c square p square. Okay, that implies log g equal to minus c square p square t plus an integrating constant I have to write, so I will take 1a. Okay. So what is this? E raised to c equal to e raised to minus c square p square t plus a. What is this? And you take the initial condition, that is from, I take equation u of 0 comma t, that is equation 4 I think, isn't it? U of 0 comma t. We have. So before that you first write what is where. This is. We can take, shall I take g equal to a dash e raised to minus c square p square t. Okay. This is your g. And once again f double dash plus p squared f equal to 0 implies, what is your f? You have to write the auxiliary equation, isn't it? This is nothing but, this is d squared plus p squared into f equal to 0. Therefore, what is the solution for this equation? Here what is the auxiliary equation is m square plus p squared equal to 0. What is m? Plus or minus ip, isn't it? Therefore, what is your f? Therefore, f is equal to a cos, I take a1, a cos px plus b1 cos sin px. Is it clear? This is ordinary differential equation. Okay, to solve ordinary differential equation, write the auxiliary equation. Then after writing the auxiliary equation, only the complete integral A complementary function alone arises because here there is no function. Okay. Therefore, this is our f, and we are finding our f and g. We are finding our f and g. Okay. After finding f and g, what is our u? Therefore, u of x comma t equal to f of x into g of x. Therefore, a1 cos px plus b1 sin px into this is a dash e raised to minus c square p square t. Now we use the initial condition to find these constants. Okay. So from equation 4, u of 0 comma t equal to 0, isn't it? That is, what is this 0? 0 is for x. When x is equal to 0, u of 0 comma t equal to 0. Therefore, you put x 0 here. So, what is this? Sin 0 is 0. Therefore, a1 cos x will be there. Isn't it? a1 cos x will be there. Is it okay? Therefore, 0 equal to a1 cos x. That is cos 0 is 1. So, I can write that also. When x is equal to 0, this is a1 cos 0 plus b1 sin 0. Sin 0 is 0, therefore a1. And this one is a dash e raised to minus c square p square t. Can you find what is this c? What is this a dash? When t equal to 0, what is the a dash will be there? When t equal to 0, u of 0 comma 0 is, what is u of 0 comma 0 here? Can anybody guess? Now, u of 0 comma 0. Does u of 0 comma t equal to 0 for all t greater than or equal to 0, isn't it? Therefore, when t equal to 0, u of 0 comma 0 equal to 0. So, in that case, what is this? This equation is 6 or 7? It's 6, I think, isn't it? U of 0 comma 0 equal to 0 implies equation 6. Equation 6 becomes x equal to 0 and t equal to 0. Therefore, 0 equal to a1. This is a dash. Is it okay? But keeping a dash is not equal to 0, we must have a1 equal to 0, isn't it? Because we don't know what is, this is a dash into this one is g of t. If this one equal to 0, then that term, entire term will be 0. So I take a equal to 0 here. That is a1 equal to 0. Okay. So from here itself we can take, since g equal to 0, g is a dash into e power c square p square t is g. Okay. G cannot be 0. Therefore, a1 must be equal to 0. I come to this case next. Okay. From this itself, I can write that a1 equal to 0. Okay. And again, u of pi comma t equal to 0. This is again from 4. U of pi comma t equal to 0. Isn't it? Implies 0 equal to, this is x is equal to pi. So a1 cos p pi plus b1 sin p pi into a dash, that is a dash, e raised to minus c square p square t. That implies 0 equal to sin p pi. What is cos p pi? Since a1 is 0, this term will be 0. This is b1 cos b p pi sin p pi a dash e power minus c square p square. Okay. So what do you get? This p will be, this implies the whole term. That is, here I have taken this is our g, therefore this one will be equal to 0. Therefore b1 sin b pi equal to 0. Okay, that implies b1 equal to 0 or sin p pi equal to 0. So b equal to 0, b1 equal to 0 gives you trivial solution. Because a equal to 0, b equal to 0, a equal to 0, b equal to 0. Therefore, the whole thing is 0. In that case, u equal to 0. U equal to 0 is a trivial solution. Therefore, we don't want that such a trivial solution. So, I take sin p pi equal to 0. Therefore, what is our p? P must be some n pi. P pi must be n pi. Okay? For n equal to 1, 2. That is p equal to n. For n equal to 1, 2. Therefore, here p equal to n, therefore this equation 6 will become what is this? U of x comma t equal to a1 is 0. So here b1 sin nx, isn't it? T equal to n. So sin nx e raised to, and a1 a dash is also there. Okay, e raised to minus p square p square. So p square is n square. Actually, as in the previous case, we have to first consider this f, then we have to consider our g. Then combining these two, we can find what is. We have to, we have this. This is our fn. This is f. But t equal to n, therefore we are having, for every n we have different n, therefore we are having fn. Similar to this, this gs depends on, that is some a dash into e raised to minus c square p square t, isn't it? Here this g is also depends on p square. Therefore, for different p we are getting different a dash. In the same manner, I combine this b1 and a dash together, some bn sin nx. Is it okay? Okay. For n equal to 1, 2, 3, etc. Thus, the general solution of star is u of x comma t equal to by taking the summation. N equal to 1 to infinity. But u of x comma 0 is what you get when t equal to 0, this will become n equal to 1 to infinity. This is bn sine nx. This is e raised to 0 is 1. Therefore, this is our series. What is this u of x comma 0 is f of x. F of x equal to sigma n equal to 1 to infinity bn sine nx. But what is our u of x comma 0? U of x comma 0 we have found in this beginning of the problem, that is u of x comma 0 will be 2k by pi into x when x lies between 0 and pi by 2, and it is 2k by pi into pi minus x when x lies between pi by 2 to pi. Okay. Therefore, this equation sigma bn sin nx equal to f of x in 0 pi. Okay, we can write. Where, what is your f of x? Where f of x equal to 2k by pi into x of x. k by pi into pi minus x. This is pi by 2 less than or equal to x less than or equal to. But here it is bn sine nx, therefore we can consider the Fourier sine series. In particularly, we can consider the Fourier half range sine series. Okay, so if the Fourier half range sine series of f of x in 0 comma pi. Here this is also valid in 0 comma pi. Therefore, we consider the Fourier half range sine series for this f of x in the interval 0 comma pi. Okay, so is what is this f of x equal to sigma n equal to 1 to infinity bn sine nx, isn't it? So this is a Fourier half range series, then it is comparable with I have taken up to 7, isn't it? I take this is our 8. So with equation 8. So this is also f of x. I have written f of x by means of Fourier half range series, but already we are having f of x in this form. What is f of x? F of x is u of x comma 0. Okay. Therefore, by comparing the coefficients, what you get here, both f of x, left hand side you are having f of x, in the right hand side you are having b1, small b1 sin 1x, and here capital B1 sin nx. Therefore, by comparing this one, we get Bn equal to this Bn for on n, isn't it? What is our Bn? This is half range series in the interval 0 to pi. Therefore, 2 by pi 0 to pi f of x sin nx dx. This is half range series coefficient. Okay. What is your f of x? F of x is given in this form. Okay, you have to write this f of x. So 2 by pi into 2 integral. That is 2 by pi integral 0 to pi by 2. In that case, what is f of x? 2k by pi x into sine nx dx plus 2 by pi by 2 to pi 2k by pi minus x sine nx dx. So integration by parts you apply. By applying integration by parts for the previous R, just I have written, I write one more step, that is 2 into 2, 4 by pi squared k. So 4k by pi squared. Okay. 4k by pi squared integral, this is x into sine nx dx, 0 to pi by 2. So similarly in the second term, 4k by pi squared, pi by 2 to pi, this is pi minus x sine nx dx. Now you apply integration by for the first one. So 4k by pi squared, and this is what is our u here? What is our u? U is your x, u is your x, and dv is sine nx dx. So what is our v? Minus cos nx by n. What is our du? Is dx. So integration by parts is uv. Therefore minus x cos nx by n, 0 to pi by 2, minus this 4k by pi squared common into 0 to pi by 2. V is minus cos nx by n into d. Okay, this is for only for the first integral. And for the second integral also you have to write 4k by pi square. Here what is our u? U is pi minus x. Okay. So pi minus x minus cos nx by n. This is v. This is pi by 2 to pi. Minus 4k by pi square. Integral pi by 2 to pi. V is minus cos nx by n, and here what is our u? U is pi minus x. Therefore du is minus dx. That must be careful in this case. So one more minus sign will be there. Now if you substitute the upper limit, the first term will be, shall we take one n outside? So minus 4k by n pi square. So upper limit is pi by 2 cos n pi by 2 minus 0, because x itself 0, so 0. Okay. And this is minus of minus plus 4k by, I take n outside, so n pi square, integral of cos sine nx by n, 0 to pi by 2. So plus the second term, 4k by pi square, I take one n outside, so I can take minus also outside, isn't it? So this is minus. So when you substitute the upper limit, it is 0. Okay? 0 minus, when you substitute the lower limit, it is pi by 2 cos n pi by 2. So minus of minus plus, plus into minus minus. So minus 4k by n pi square. This is sine nx by n. This is pi by 2 to pi. So what is cos n pi by 2? When n equal to 1, cos 90. When n equal to 2, it is cos pi. Therefore, we have some value when it is even, isn't it? When n is even, we have some value here. Otherwise, we don't have. Okay. But I just substitute. This is minus 1, 5 will cancel, 2 will cancel, therefore minus 4, 4 will become 2, a by n pi. Is it okay? Minus 4, 4 by 2 is, this is 2, okay? And 1, 5 will get cancelled. So, this 1, 5 will get cancelled, so n pi, cos n pi by 2. And what about this? This is 4k by n square pi square. I have taken this n outside. When you substitute the upper limit, sin n pi by 2. When you substitute lower limit, sin 0 is 0. So I remove that. So this is minus of minus plus. And similarly here also I have 1, 2 cancel, 5 cancel. So 2k by n pi. Cos n pi by 2. Okay. Minus 4k by n square pi square. When you substitute upper limit, it is sin n pi minus sin n pi by 2. So you compare this first and the third term, it will get cancelled because plus or minus. Therefore, we are having 4k this is 4k n square pi square sin n pi by 2. And sin n pi is 0, minus of minus plus. So 4k by n square pi square sin n pi by 2. So what you get? This is 8k, isn't it? 8k by, because all the terms are equal. Same term, twice. So just you add. So what is this? This is with bn, isn't it? Bn. Start with bn. Therefore, I take equation 8 or equation 7, I don't know. This equation, that is u of x comma t. U of x comma t equal to sigma bn sin nx e raised to minus c square n square t. So what is the equation number? This equation 7 or 8? What is the equation number for this equation u of x comma t equal to? Whether it is 7 or 8? Do you follow or not? Are you writing? Do you understand? This is equation 8, I think, isn't it? So equation 8 becomes u of x comma t equal to 8k by n square pi square, so sigma n equal to 1 to infinity 8k by n square pi square sin n pi by 2 sin nx e raised to minus c square n square. If you want, you can take 8k by pi square outside. This is equal to 8k by pi square sigma. When n equal to 1, it is sin pi by 2. When n equal to 2, it is sin pi is 0. Okay. Therefore, even terms, the term will be in the series, even terms will get cancelled. Therefore, only we have odd. So, n is odd. Okay. N is odd. Here 1 by n square sin of n pi by 2 sin nx 2 is to minus c squared n squared. Sin n 5 by 2 is what you get? When n is odd, 8k by pi square. This is, as n is odd, I can take n is equal to some 2m minus 1, isn't it? When m equal to 1, what do you get? 1. When m equal to 2, you get 3. Okay. Therefore, this n will be of the form 2m minus 1, where m equal to 1 to infinity. Is it okay? And what will get? This is 1 by, I can take m square. What is your m? M is equal to 1 to infinity, like that. Okay. Is it clear or not? Instead of instead of n, I can take 2n minus 1. Since n is odd, I can take 2n minus 1, where n equal to 1 to infinity. When n equal to 1, it is 1. When n equal to 2, it is 3. When n equal to 3, it is 5, and so on. And what about this sign of, when n equal to 1, it is positive, that is plus 1. When n equal to 3, it is minus 1. And alternatively, plus 1, minus 1, etc. Therefore, what you get? This is minus 1. If it is, I just put if it 1, n equal to 1 starter. Therefore, I get minus sign first, but I should not get minus, so I add 1 n. So sin nx e raised to minus c squared n squared. So this is the general solution of the given equation. That is, this will give you the water. Write here n plus 1 sin of 2n minus 1 e raised to minus c squared n squared. This n squared also 2n minus 1, isn't it? So c squared 2n minus 1 the whole square into. Replace n by 2n minus 1 because 2n minus 1 is odd. So this is the thermal, that is temperature distribution of the given problem. Okay, tomorrow we will continue. That is, we will continue in the sense we will do the what time? Who is alone at 4:10 p.m. Okay, in the Google Classroom. I will send you the Google form at 4:10 exactly. Thank you.